topic. Okay. So what is this all about? What is this linear algebra and the differentiation? So it all centers around determining the slope of a curve, determining the gradient of a function. Of course, you know, we have a function or something like this. We have our graph here. We have the y-axis and the x-axis. So in some cases, it becomes very difficult to determine the gradient, especially if you have a curve like this one here. Okay. So what would be the gradient of this kind of curve? So the only way to determine the gradient of a curve like this one here is to go through what we call differentiation. Differentiation helps us to get the slope of a function. At a particular point, for instance, I could be looking for the slope at, let's say, point B here. So I can determine the gradient at that point. Of course, here I have my y and my x. And if this could be x to power n, the dependent variable is the y and the independent variable is the x. So the gradient of that kind of a curve is denoted as dy dx, which most of you have already seen from your earlier studies. So for linear relationships, a line like y is equal to mx plus c, dy dx will be the m, which is the constant. And if we do it like this, what we get is what we call the first derivative. What we get is the first derivative. If it is a parabolic relationship, like this one here, y is equal to ax squared plus bx, dy dx would be that 2x plus b, and that would be the first derivative for our parabolic relationship. So the rules of finding these derivatives are several. We shall review some of those. The first one is what I'll call the basic rule of differentiation. The basic rule of differentiation, where we have a function, y is equal to x to power n. So in those circumstances, dy dx will be nx n minus 1. So what is happening here? What's happening is that to get the dy dx, I bring the powers on x down, then I reduce the powers of x by 1. I reduce the powers of x by 1. I will reduce the powers of x by 1. So this is the basic rule of differentiation. And that's the first thing you're going to write in our books. Basic rule, let's write this one here. Basic rule of differentiation. Y is equal to x to the power n. If that's the function, then dy dx is equal to n x n minus 1. And this one, we call it the first derivative. The first derivative. Now let us paint a picture. Assuming we have y is equal to x to power 3. Following the basic rule, dy dx will be 3x, 3 minus 1, which comes to 3x squared. Okay? If we have y is equal to, let's write in our books. If we have y is equal to x to power 3, dy dx will be following the basic rule because I'm following the basic rule, okay? The basic rule is that dy dx is equal to nx n minus 1. So that's exactly what I'm doing right there. Dy dx is equal to 3x, 3 minus 1, which is 3x squared. Next, I have y is equal to x to power 5. I have y is equal to x to power 5. So who can give me the dy dx in the chat? Following the basic rule, following our basic rule is that if y is equal to x to power n, dy dx will be nx n minus 1. So following that, what is our dy dx? Anybody in the chat? Anybody? Some contributions? 5x. Anybody? Hello. 5x to power 4. Correct. 5x to power 4. That's correct. 5x to power 4. That's correct. Okay. So that is our basic rule number 1. Let us go to basic rule number 2. Basic rule number 2, what are we saying? If you have a function which is kx to power n, and k being a coefficient, then dy dx will be nk x n minus 1. nk x n minus 1. Let's write this in our books. Functions with coefficients. Y is equal to kx to power n, k being a coefficient, dy dx would be nk n minus 1. Okay, let us explore. If we have y is equal to 5x to power 3, dy dx is going to be 5 times 3, x 3 minus 1. And that's going to give us 15x squared. That will give us 5 is the coefficient, okay? Where 5 is what we call the coefficient. We refer to 5 as the coefficient. So we have y is equal to 15x squared. Y is equal to 15x squared. Okay, I have one for you to try. Let's try out the next one. If I have y is equal to 10x to power 5, what would be our dy dx? What would be the dy dx? This is for you to try there in your books. Dy dx. Anybody in the chat? If we follow the basic rule, dy dx dy dx would be 50x to the power 4, correct? 50x to the power 4. So that is 10 times 5. 10 times 5. x5 minus 1, which brings us to 50x to the power 4. 50x to the power 4. 50x to the power 4. Good. Let's move to the next one. The next rule, functions with constants, like this one here. If I have y is equal to x to the power n plus c, where c is the constant, dy dx is nx n minus 1. In principle, constants will disappear on differentiation of functions with constants. Let us put this one down in our books. I'll give you half of a minute. Okay, let's try out the first one. If we have y is equal to 2x squared plus 7, dy dx would be, our dy dx will be 2 times 2 there, x2 minus 1. The 7 disappears, comes to 0. So therefore, our dy dx will equal to 4x to the power 1, which we don't usually write. You may not put the 1 up there. The constant, which is 7, disappears on differentiation. The constant, that's 7, disappears on differentiation. Good. Let us go to this one for you to try. Y is equal to x to the power 4 plus x plus 9. Share with me in the chat. Y is equal to x to the power 4 plus x plus 9. Share with me your answer in the chat. Anybody? Two people have tried. Two people have tried. So dy dx, we have 4x to power 3 plus 1. Good. Dy dx would be 4x power 3 plus 1. 9 is a constant, so it will disappear on differentiation. The constant disappears on differentiation. As a basic rule. So ideally, if I'm to elaborate on this, there's some simple mathematical explanation. Let's have dy. Okay, let me first of all rewrite this equation. This equation is y is equal to x power 4 plus x to power 1 plus 9x to power 0. This 9 that you see here has an x, but the x is to power 0. Any number to power 0 is, yeah, anybody who knows? Any number to power 0 is what? Anybody who knows? Any number to power 0 is 1. Okay? Any number to power 0 is 1. So that's why we don't put the x on the 9 or on the constant. Therefore, dy dx will equal to, there is a 1 here and a 1 here. So it's equal to 1 times 4, x4 minus 1, plus 1 times 1, x1 minus 1, plus 9 times 0, x0 minus 1. So someone wanted me to elaborate, so that's why I'm doing this. Dy dx, therefore, comes to 4x. This one is a 4. This one is a 3. Plus this one is a 1, which we don't put. And this one is a 0. Okay. So that's to power 0. Then, of course, this one being 0 everywhere, so it becomes a 0. So we have nothing there. So to write this one better, any number to power 0 is a 1. So this one we end up with dy dx, which is equal to 4x to power 3 plus 1. Because this one being power 0 is a 1. So we write it as 1. So that is the elaboration. You wanted to see from first principles, but you don't need to do all this in the exam. All we need is the dy dx. All we need is the dy dx. You may not really spread it like that. Okay, so that is the first segment of our lecture. Next, we are going into the application of dy dx. The notes are yours. You get a copy of the notes and the recorded video. The video is recorded, so you get a copy. Next, you look at the practical application. Where do I apply this? Because usually students ask me, where do we apply this? Where do we apply dy dx? So in the second segment of our discussion, we look at the application of dy dx. And what are we saying? We are saying that differentiation helps. Just a minute. Just want to first get these things here. Just a minute. Okay, so the question is, where do we apply these kind of things? Are we just wasting our time? No. These things are actually highly examinable. So we are saying on the slide that efficiency helps to show the rate of change of the dependent variable with respect to an infinitely small increment in the value of the independent variable, which is in most cases the worry of managers. For instance, if we are producing, let's say 20 pieces, and now we want to increase our production by 1 piece, 21 pieces, what would be the impact on the costs? What would be that incremental revenue? What would be that incremental cost? So this is where the y/dx comes in. And thank God today we have computers. We can simply input this information in a software, and then we are able to get results instantly. We see the y/dx being applied in determining the marginal cost, where marginal cost is that small change in cost as output increases by a unit. In fact, marginal cost is the gradient of the cost function. The dCdq, Q being the quantity, and then C being the total cost. If you get the CdQ, you will have got the marginal cost, which is very, very instrumental in decision making. Because managers would say, okay, if we increase our production by 1 unit, the increment in the cost is going to be this much. Next is marginal revenue. Marginal revenue measures that change in revenue when we increase our production by a unit. In fact, if you get the RDQ, where Q is the quantity and R being the total revenue, you will have got the marginal revenue. From economic theory, it is true that profits are maximized at that point where marginal cost is equal to marginal revenue. So it will require us to do the dCdQ for marginal cost, the RDQ for marginal revenue, to be able to advise management the point at which they're likely to maximize profit. You may not do this as the accountant, but you may have an economist, someone in charge of this. And of course, you being one of the people managing finances, it should be a shock, shouldn't be a shock that the person is talking about marginal revenue and then you are seeing stars. So that's why we bring you some of these economic concepts, not that you're going to do the economics, but at least if you are the boss, if you're the CEO, you're the MD, and then your economist talks about marginal revenue, marginal cost, you shouldn't be seen as an idiot. Because if you don't know that, then you'll be looking like an idiot because you're the managing director, but you cannot know the concept of profit maximization. So we bring this in your course so that you don't look angers when your juniors are presenting this to you. Average cost is the cost per unit of output, the cost per unit of output. From time to time, your economist will be talking about average revenue. And of course, you will know that that is the cost per unit. Again, from time to time, your economist will be coming to you as the MD and will be talking about average revenue. So when he's talking about average revenue, he's talking about the revenue per output, which is indeed the price. Okay, price, which we refer to as the demand function in economics. So when we talk about demand function, we are talking about the average revenue And again, we are talking about the price. I need to mention that the examiner has been very tricky these days, where he inverts this equation. So from this equation, you know that revenue is equal to average revenue times quantity, if I express revenue as a function. So again, it means that revenue is equal to price times the quantity. You're going to see that most of the questions, the examiner inverts the equation, and of course, people get lost if he uses revenue instead of average revenue. Again, your economist will be talking about the break-even point or the management accountant. The management accountant will be talking about break-even point. And what does it mean? It means the point at which you don't make a profit or a loss. And again, it's a derivative of depreciation. For purposes of appreciating our knowledge and to support the foregoing discussion, we are going to use this question, which comes from May 2021. May 2021, we were given this question and we are required to determine the company's marginal revenue, marginal cost, the quantity at which we shall maximize profits, and then the price at which we should sell in order to maximize the profit and the profit to be maximized. So I'm giving you 5 minutes to write the question in your books because this is going to support our foregoing discussion. Let me know when you're done. I unmute. We continue. All right, so it looks like the figures are confirmed. Marginal revenue for marginal revenue, isn't it, for Q? That's 400, it's 400Q. Huh? This was a 400Q. I want you to look at the question clearly. This is 400Q. 400Q minus 4Q squared. Okay, so let us go to the next part, which is determining the quantity at which we maximize profit. So what do we do? From economic theory, we know that the point of profit maximization is the point where marginal revenue, is equal to marginal cost. So I equate the two equations from the first part. This is where I equate the two. And then, of course, collect like terms here. And of course, the point at the quantity that will help us to maximize revenue comes out as 30 units. I want you to confirm whether this is what you get. Confirm that this is what we get. Continue. So is this correct? Is this correct? Are we good? Okay, so if this is okay, we go to the price at which we shall sell. Now, as I've mentioned, price is the average revenue, which is going to be revenue divided by the quantity. So our revenue function is 400Q minus 4Q squared divided by Q. But we have already got the Q as 39 units. Therefore, the price will be got by substituting everywhere 39. And what I have here is a figure of 244. So for us to maximize profit, we have to sell each unit at a price of 244. So I want you to confirm this as well. We go to the last part of our question. Okay, so that is okay. Please, more people, let's more people confirm. Are we okay with this? Are we okay with this? Okay. So finally, we have the profit that we are maximizing. Now, you know that from your accounting, profit is equal to revenue minus cost. We have our revenue function. We also have our cost function. Now, since all these functions are expressed in Q, value of Q, we shall substitute Q everywhere. And of course, we find that our profit is 7575. The profit that we ought to maximize comes out as 7575. So I'll give you 5 minutes to write, put down this. If there are any questions, let me know. If there are no questions, we shall sign out.